So hello everyone. Today we will study second shifting theorem. Till now we have seen two properties of Laplace transform. One was change of scale property and the second one was first shifting theorem. So today we will study about the second shifting theorem. Second shifting theorem states that if L of f of t is f of s and if g of t is defined in this manner as g of t equal to function of t minus a for t greater than a is equal to 0 for t less than a, then L of g of t is e raised to minus as into f of s. Okay, you will be defined some function g of t, then we have to write L of g of t is equal to e raised to minus as into f of s, where a can be got from these inequalities, t greater than a, t less than a. We can get a from here. Next we want is f of s. F of s is L of f of t. Now this f of t has to be got from this function. G of t is equal to function of t minus a. This is function of t minus a. We require f of t. So put a equal to 0, put a equal to 0 and then you will get f of t. So whatever is the function f of t, calculate the Laplace transform, that will become f of s. So L of g of t will become e raised to minus as into f of s. So the function will be defined in this manner. Our aim is to get the value of a and the function f of t, calculate L of f of t, replace it by f of s, and then L of g of t will become e raised to minus as into f of s. For example, find L of g of t where g of t is equal to this, t minus 1 the whole square for t greater than 1 is equal to 0 for t less than 1. G of t is defined in this manner. So now we have to apply, whenever g of t is defined in this particular manner, we have to apply the second shifting theorem. Whenever g of t is defined in this particular manner, we have to apply the second shifting theorem. So what is second shifting theorem? If L of f of t is f of s and if g of t is function of t minus a for t greater than a is equal to 0 for t less than a. So here we are given g of t is t minus 1 the whole square for t greater than 1 and is equal to 0 for t less than 1. Similar form we have. So we can say that a value is equal to 1. If I compare both the functions, a value will be equal to 1. So we require a and we require f of s. F of s is got by calculating L of f of t. So how to get f of t? F of t is got from this function. So what is the function here? We have got t minus 1 the whole cube, where a is equal to 1. So if I remove this minus 1 part, the remaining is only t square. So which means that f of t will become t square. We are given f of t minus a. If I remove this minus a from here, I will get f of t. So same way, if I remove minus 1 from here, I will get f of t as t square. So we have f of t as t square and a is equal to 1. Okay, you are having f of t minus a. So if I remove minus a, if this minus a is not there, I will get f of t. Similarly, if this minus 1 is not there, I will get t square as f of t. And a is equal to 1. So calculating, now we want f of s. F of s is calculated by L of f of t. So L of f of t means L of t square. Now L of t square, we know that L of t raised to n is gamma n plus 1 upon s raised to n plus 1. So gamma n plus 1 is gamma 3 upon s cube. Gamma 3 is 2 factorial. So I will get 2 upon s cube. So 2 upon L of t square is 2 upon s cube. Now 2 upon s cube is f of s. So from the second shifting theorem, I can write L of g of t is equal to e raised to minus as. E raised to minus a is equal to 1. So e raised to minus s into f of s. F of s is 2 by s cube. So it is 2 e raised to minus s upon s cube. Okay, nothing else we have to do. Just calculate the value of a, calculate the function. Calculate L of f of t and then whatever answer we get, multiply that by e raised to minus as. Okay, so we have to calculate, get the value of a. From this, get the value of the function here. calculate the Laplace transform of the function that is going to be f of s. Then L of g of t is e raised to minus as into f of s. Second problem, same way, only the function is different and the limits are different. So find L of g of t, where g of t is cos of t minus 2 pi by 3 for t greater than 2 pi by 3 is equal to 0 for t less than 2 pi by 3. Only if the function is defined in this particular manner, we can apply the second shifting theorem. Okay, not for any other function. Only it has to be 0 for t less than, and it has to be function of t minus a for t greater than a. Then only we can apply the second shifting theorem. So now we have to write our a and the function. Now a is the limits here. Whatever the inequality we are given, t greater than a, t less than a, we can write the value of a. So a is equal to 2 pi by 3. Now when I remove this minus 2 pi by 3 from here, I will be left with the function cos t, which means that f of t is equal to cos t. Okay, so from second shifting theorem, to a is equal to 2 pi by 3 and f of t minus a is cos of t minus 2 pi by 3. So if I remove this minus 2 pi by 3, we will be having the function as cos t, which means that f of t is cos t, a is equal to 2 pi by 3. Once we get f of t, we have to calculate L of f of t to get f of s. So calculating L of f of t. L of f of t is L of cos t. We know L of cos t is s upon s square plus 1. This becomes our f of s. So from the second shifting theorem, I can write L of g of t is equal to e raised to minus as. A is 2 pi by 3. So e raised to minus 2 pi by 3s into f of s. F of s is s upon s square plus 1. Okay, the same way, just our aim is to get the value of a and the function f of t. Whatever is the function f of t, you calculate the Laplace transform, that will become f of s, and then apply the second shifting theorem, which states that L of g of t is e raised to minus as into f of s. F of s is L of f of t. F of t is got from the function f of t minus a. This is cos of t minus a. So if I remove this minus 2 pi by 3, we will have only cos t. That becomes a function function f of t. Next problem. Find L of g of t, where g of t is equal to e raised to minus b into t minus a for t minus a the whole into t minus a the whole cube for t greater than a is equal to 0 for t less than a. So again here a only is given, so a is equal to a itself. Now remove this minus a from the whole function. If we have minus a, remove this minus a. So what will have? E raised to minus bt. Again remove this minus a, will have t cube. So we can write the function f of t will become e raised to minus bt into t cube. That minus a has to be removed. Minus a should not be written over there. Whatever is function of t minus a, this minus a has to be removed. So e raised to minus b, if I remove my minus a, I will get e raised to minus bt. Again, if I remove minus a from here, I'll get t cube. And a value is a itself. There is no change. So calculating L of f of t. Now L of f of t is, we are having L of e raised to minus bt into t cube. So you are having a function multiplied by e raised to minus bt, which means we have to apply the first shifting theorem. So what is the first shifting theorem? Whatever is the function other than e raised to, calculate the Laplace transform. So what is the Laplace transform of t cube? It is gamma 4 upon s raised to 4. Gamma 4 upon s raised to 4. In that answer, replace s by s plus b. So we have gamma 4 upon s plus b whole raised to 4. But gamma 4 is 3 factorial. So we get 3 factorial upon s plus b whole raised to 4. Okay. So since we have a t cube multiplied by e raised to minus bt, we have to apply first shifting theorem. To apply first shifting theorem, first calculate the Laplace transform of t cube. Now t raised to n is gamma n plus 1 upon s raised to n plus 1. So we will get gamma 4 upon s raised to 4. Gamma 4 upon s raised to 4. And then in that answer replace s by s plus b. So we will have gamma 4 upon s plus b whole raised to 4. Gamma 4 is 3 factorial. So 3 factorial upon s plus b whole raised to 4. 3 factorial is 6. So 6 upon s plus b whole raised to 4. So now we have got f of s. A is already equal to a. So from second shifting theorem, we can write e raised to minus as into this answer. Okay, so here we are applying the second shifting theorem to get L of g of t. But to get L of f of t, we have to make use of first shifting theorem because t cube is multiplied by e raised to minus bt. So in this problem, L of g of t will become 6 e raised to minus as upon s plus b whole raised to 4. Next problem. Find L of g of t where g of t is e raised to t minus k for t greater than k is equal to 0 for 0 less than t less than k, or t less than k I can say. So here a is equal to k. A is equal to k. Remove minus k from here. Get the function f of t. So if I remove minus k from here, the function will become e raised to t. So I can write f of t is equal to e raised to t. A is equal to the limits here, that is k. And if I remove minus k from here, we will be left with the function e raised to t. That is f of t is equal to e raised to t. A is equal to k. Calculate L of f of t. That is L of e raised to t. E raised to t is 1 upon s minus 1. This is our f of s. Substituting in the second shifting theorem and getting L of g of t. A is equal to k and f of s is 1 upon s minus 1, which is e raised to minus ks upon s minus 1. It's a simple second shifting theorem. If you don't remember this, then you have to use the basic definition of the Laplace transform and eval. That becomes very lengthy. So if you remember the second shifting theorem, such types of functions can be easily calculated. But the function has to be defined in this particular manner only. F of t minus a for t greater than a is equal to 0 for t less than a. So we have some practice problems here. This we can apply the previous method. For this we can apply the second shifting theorem. So here a will be equal to alpha and function will become f of t will become cos t. So thank you. See you in the next lecture with the next property of Laplace transform.